There are two things I want to continue for Class A and Class B. It's a very short video. The first thing is actually the crossover distortion understanding. So the crossover distortion understanding is that a crossover means that it cross over from the zero voltage zone, from the negative to the positive. So at this side, the negative to the positive, there will be a crossover distortion. At this point, at this line where they cross, where at this, yeah, so I think you know what I mean. So at this line where they cross from negative to positive, you have a distortion over here. That's all. The second thing I need you to take note is Class A amplifier. Okay, Class A amplifier. So what is Class A amplifier thing? Is that how it actually changes all the voltage. Okay, how it changes all the signals, the negative signal to the positive side. How it actually do that? Okay, how it do this is actually using DC offset. Okay, ensuring that all current flows in a single direction. What does this mean? Okay, if I repeat again, because you are connecting AC source, right? Input. So when you're connecting AC source, you're gonna have a sinusoidal ding 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 ding. You're not going this way. If you have a DC circuit, you're gonna have a smooth straight line down, right? So the difference between DC and AC is that DC is like that. AC is ding 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 ding. Okay. So for AC rise, you want it to be moving in the same direction, meaning you're gonna DC offset all the things. So you're gonna only take in only this the positive side. Okay, so for the ding 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 one, because the current may be flowing in both directions. I don't know. Damn. Current may be flowing in two directions lah. But in order to do that, you will have a DC circuit, DC offset. Okay, DC offset. Remember, this is the term, so that you can actually cause the class A to actually output all the same direction signal. So you're ensuring that all the currents are moving in this direction. Okay, 1, 2, 3, 4, 5. Okay, they are moving in this direction. Ensuring the current is moving in this direction. So the current at this point, it is larger than the point where it opens the gate, if you remember. So if it opens the gate, you're actually allowing all the voltage to flow in. Right? This is the voltage to flow in this direction. So this allows everything to flow. And then the question may ask you that how do you amplifying, what is the difference between amplifying a current amplifier and amplifying a voltage? Okay, amplifying a current you can connect in this manner. Okay, but however, amplifying a voltage, you can employ this one. You just draw this one. That's all. So amplifying current, you get this one. Amplifying voltage, you get this one. Okay, I may be wrong. Damn. Okay, so let me repeat everything. Okay, just to make it everything clear. Hopefully this is clear. The voltage goes in this direction. Right? The voltage goes in this direction. So if you have a input base of 0.6 voltage, you can actually open up the gate, allowing the voltage to flow through. Allowing the voltage to flow through in this manner. Okay, allowing the voltage to flow through in this manner. Like in this manner, maybe it flows over here also. Okay. If you were to open up the gate, you allow the voltage to flow in this direction. And then this one will goes in this direction, this one will goes in this direction, right? So as you know that voltage and current are flowing in the opposite direction, if a voltage is flowing in this direction, the current is going to flow in this direction. So if this gate opens up, the current gonna flow through, right? So there will be more. So as the current from this source is flowing through this thing, okay, you're gonna amplify the current over here, right? So this is simply the case of amplifying the current. As for amplifying the voltage, it is the same thing as this one. It's the same thing as this one. However, we can use them. So BJCs are normally thought of as current amplifier, which is this one that I'm talking about, right? However, we can use them to amplify voltage. So we can use this one, the same thing, to amplify voltage. but it's being confused by the V output thing. This is actually connecting a voltmeter over here as a parallel circuit. So you can actually measure the voltage between the potential difference between this point and this point. So if you were to measure this one, because you know the voltage is flowing through this manner. So if it's if it's an open circuit, the voltage cannot flow through here, it cannot flow through this BJT. So it will start over here and it will stop, right? It will stop over here. However, if you have a solar panel, there's a voltage flowing in this direction. Okay, opening up the gate over here, you actually opens up the gate and then you allow the voltage to flow through, stream through. So there will be more voltage over here than here, right? So the voltage is being amplified from this point to this point. So let me repeat again. Voltage is being amplified from this point to this point. Current, in another case, is amplified from which point to which point. Good job. Current is being amplified from this point to this point. Okay, it's the other way around. Okay, or maybe voltage. In other words, you can measure, but you cannot. Yeah, when you're measuring voltage, you can only measure in parallel. When you're measuring current, you're gonna measure in terms of series. You're gonna connect in series. So this is where you place your ammeter. This is where you place your voltmeter in parallel circuit. Okay, so yeah, it is decently clear. Hopefully this is very important. So I hope that you can understand this. So I'll see you in the next video for other stuff.